Hi, welcome to Elecom Edu. Okay, so now we will see another one thing, right? Okay, so already I said electronics. So what is electronics? To study about the electrons, right? Okay, so now we studied two different types of semiconductor, N-type semiconductor as well as P-type semiconductor. So in this N-type semiconductor, where electrons are available, and in p-type semiconductor where holes are available. Okay, either it is electron or hole, both can able to flow from one end to another end. Okay, if suppose the electrons are flowing from one end to another end, we used to call it as a current. Okay, so current is nothing, it is a flow of electrons, right? The holes are moving, that also we used to call it as a current only, but that current we used to call it as a conventional current. So conventional current in the sense it is a reverse current or opposite current, right? It is a reverse current or else it is a opposite current. Okay, right. So if it is a N-type semiconductor, the electrons will flow from one end to another end. We used to call it as a current. If it is a P-type semiconductor, the holes are moving from one end to another end, and we used to call it as a conventional current. Okay, right? So this N-type semiconductor where pentavalent impurities are used, and in a P-type semiconductor where trivalent impurities are used, right? So here we have to present two words. So one is a donor and another one it is a acceptor. Remember, the trivalent impurities are acceptor impurities, and the pentavalent impurities are donor impurities, right? Because what is happening in the pentavalent impurity, 5 valence electrons are there. Okay, so 5 valence electrons of pentavalent impurity gets bonded with 4 valence electrons of the silicon, right? So one valence electron from the pentavalent impurity is left. So means that it is donating to the host. But here in the trivalent impurity, it is accepting the electrons from the host. So that's why it is termed as an acceptor and it is termed as a donor. So donor impurities are pentavalent and acceptor impurities are trivalent. Okay, clear? Right. And here at the same time, you have to know about the charge carriers. So one more thing you have to know, that is the charge carriers. Generally, it is of two types. One is a majority charge carriers and another one it is a minority charge carriers. We should know what is this majority charge carriers and minority charge carriers. So if it is a majority charge carrier, the major is that particular charge carrier. If it is a minority, that will be the less, right? Again, we will take this N-type semiconductor and P-type semiconductor. You already know why we called it as a N-type semiconductor. Why we called it as a N-type semiconductor? Because it is a negative type where electrons will be more. So, if electrons are more, then holes will be less. So, electrons are more and holes will be less. If it is a P-type semiconductor, you already know P-type semiconductor means holes. So, holes are more and electrons are less. So, if more, that is nothing the majority charge carriers. If it is less, that is nothing the minority charge carriers. So, in N-type semiconductor, electrons are the majority charge carriers and holes are the minority charge carrier. In P-type semiconductor, where holes are the majority charge carriers and electrons are the minority charge carrier. So it may be N-type semiconductor or else it may be P-type semiconductor. Both have the charge carriers, but one charge carrier rate will be more when compared with the another charge carrier. Okay, so if you want to design any electron devices, so these are the basics to design any electron devices. Either it may be the earlier stage devices or else currently whatever we are using. Okay, so this is a complete basic how to design a semiconductor, otherwise how to fabricate the semiconductor. So from the forthcoming classes, we will see what are all the electron devices, how those electron devices are fabricated by using these extrinsic semiconductor. Okay, so study this well, and by the next class we will check about what are the electron devices and how to fabricate the electron devices and forthcoming things. Thank you.